This is more of a general review of, not a review, I shouldn't say that. It's a little bit different than what we've been doing because we're kind of given more information, but we just have to take it sentence by sentence and write down what we know, and then you should see how things will come together. And they'll come together differently. This may not be as straightforward as the previous stuff, but all your information is given. You just have to record it and make sure you're putting down the formulas right, differentiating the right formulas, and so on. So the radius of a circle is decreasing at a constant rate of 0.7 centimeters per second. So that's telling me that dr dt equals negative 0.7. They want in terms of the circumference. Now, circumference is 2 pi r, right? What is the rate of change of the area? So, what's the area formula? Pi r squared, circle. So if they want the rate of change of the area, they want us to differentiate that. So dA dt equals 2 pi r dr dt. What is the rate of the change of the area of the circle, and what do we know that we can plug in? dr dt is negative 0.7. And pay attention to the first phrase in that sentence, in terms of the circumference. Right now, if we leave it as 2 pi r times negative 0.7, right now our rate of change of our area is in terms of the radius. We want it in terms of our circumference. So we're going to take out the 2 pi r and just replace it with capital C. And that's it. Your rate of change of your area is negative 0.7 times your circumference. They didn't give us like a number like we've been used to seeing, like what is the rate of change of the area at the moment that the radius is 5 or at the moment the circumference is 5. They didn't give us at the moment, so we just had to do it in terms of circumference. Kind of like your homework last night, number 8 said to find how fast the water level was changing in terms of H. They didn't tell us really for the first time, they didn't tell us what to plug in for H. They just wanted the answer in terms of H. So that's it. You're done. There's the rate of change of your area in terms of the circumference. What? So number 2 tells us the side of the square. We'll call the side of our square x. It's increasing at a rate of 2 inches per second. So what equals 2? Good. dx dt equals 2. In terms of the perimeter, what would be the equation of the perimeter given the way I've labeled my 4x? What is the rate of change of the area of the square? So first of all, we need a formula for the area of our square. What's the area of the square? X squared. And if we want the rate of change of the area, we need to differentiate that. So dA dt equals 2x dx dt. So what do we know that we can plug in? Okay. And that all equals 4x. They want our answer though. We don't know. Again, I'll say this again. They didn't say to find the rate of change of the area when x equaled 7. Or when they didn't give us a number there. They want the rate of change of the area in terms of the perimeter. Well, right now we have the rate of change of the area in terms of the side length x. So we now just need to replace that with P. So dA dt just equals P. Any questions on that? Just a few more formulas floating around, I would say, with this kind, when they have you do it in terms of another variable.
We should get the reference table that we get for the time.
So on number 3, we're dealing with a ripple in the pond's surface, and that's a circle, such that its circumference increases at a rate of 25 feet per second. So what equals 25? D capital C dt. So given that they gave me the rate of change of the circumference, I also think coming up with the basic circumference formula and differentiating that is important. So what is the circumference formula? Circumference equals, we'll stay with r's, 2 pi r. So if I differentiate that, I get dc dt equals 2 pi dr dt. And I know that dc dt is 25. And that also tells me what dr dt is. Do you see that? If I divide both sides by 2 pi, I can also get dr dt from that. So even though they only gave me dc dt, I can figure out what dr dt is as well. Then they want how fast is the area increasing when the circumference is 49. So here's our area. So they are giving us at a certain point in time. This isn't in terms of another variable this time. They're telling us at a specific moment. So let's just go, we're looking for the rate of change of the area, so let's just go to our area formula, pi r squared, and differentiate that. dA dt equals 2 pi r dr dt, and plug in what we know. So what do we know? Well, we only know dr dt right now. We don't know r yet. But that's not because we want our answer in terms of r. It's because they haven't told us r verbatim, but they've given us enough information to be able to figure out r. Okay? Because they want this rate of change of the area at the moment when the circumference is 49 pi. If your circumference, which is 2 pi r, not quite, if your circumference, which the formula for is 2 pi r, is we're looking for it at the moment that the circumference is 49 pi, we can solve this equation for r and find out what r is at this moment when the circumference is 49 pi. So divide both sides by 2 pi. 49 pi divided by 2 pi, your pi's will cancel, and your r is 49 over 2. So now if we go back to our rate of change of our area, we do know our value is 49 halves, and our dr dt is 25 over 2 pi. And then we can reduce. Your 2 pi and 2 pi will cancel, and then it's just 49 times 25 over 2.
Couldn't you just plug in 49 pi for 2 pi? Pretty sure it comes out.
Oh yeah, I didn't even see that.
Yeah, that's what I was trying to say.
2 pi r is 49 pi. So because I was so literal about it, like I wanted so badly to plug in for r, I went and found my exact r to plug in. But you're right, if you can sub out that whole 2 pi r chunk with a number, 49 pi, you would get the same thing. You're right. And then 49 times 25 is just gonna need a little work. 18, carry the 1, 9, 5, 12, 1225 is the rate of change of your area. Feet squared per second, right? Area is feet squared. And our unit of time has been seconds. Good? So it's a little bit, it's just more of a maze, because there's more formulas popping around. Just take it one sentence at a time and see what you can find out, and if you find out something that you don't end up needing, who cares? But if you just take it slowly, you'll be better off. Alright, surface area of a cube. So first of all, I'm going to draw a cube to give me a visual. I'll make the side length x again. What's the surface area formula for a cube? So surface area equals, one side is x squared, and we have 6 of those, so 6x squared is kind of where that comes from, right? So we were just told the rate of change of the surface area, so I'm going to differentiate this. So d of SA over dt, I know it's a little weird because surface area is two letters, but that's the rate of change of my surface area equals 12x dx dt. And so far I just know that this rate of change of my surface area is 36. More to come. How fast is the volume changing? We need a volume formula. What's the volume of a cube? X cubed. So we want to differentiate that. dv dt equals 3x squared dx dt. At the instant, the surface area is 300. So at the instant, the surface area, which equals 6x squared, equals 300. So at the moment the surface area is 300, what's our x value? We divide both sides by 6, we're going to get x squared equals 50. Yes? So x equals 5 root 2. So we need an x value, we have it, it's 5 root 2. We need a dx dt value, which we don't have, but if we go back here, since we now know what the x value is at this moment, we can find dx dt. So I'm going to go back here, I'm going to plug in a 5 root 2 and solve for dx dt at this moment. So I'm going to first divide that 12 over, which is going to make this 3. And then divide my 5 root 2 over. So 3 over 5 root 2 equals dx dt. And then I can use this up there along with my x value of 5 root 2 up there. So dv dt equals 3. What's 5 root 2 squared? Times dx dt, which is 3 over 5 root 2. So your 5 and your 50 can cancel into 1 and 10. And then I just have 90 over root 2. I'm going to rationalize. Is that what happens when you rationalize? 90 root 2 over 2 just becomes 45 root 2.
I agree with you, we need that reference table for this.
Surface area, I've used that formula once in my entire life.
For a cube,
I've used that once.
well, get prepared because it's gonna be for a sphere as well.
Geometry.
I'll ask Mrs. Hill. If they will give it to you on the AP exam, I will give it to you.
Well, we're not taking it.
You are next year.
Yeah, you would have a lot.
I'm here to prepare you for that. That's the point of this class.
We're not taking it.
Sorry. All right, do you want to try this one on your own?
No.
No. Yeah.
Let's go for Let's let Sam do it all in all right.
All right, we'll do this one together, and then if we have time, we'll try 6 on our own.
I'm just really upset right now.
Volume of a cube. Draw your cube. What's the volume formula for a cube?
I'm sure.
So dV dt, if we differentiate, is going to be 3x squared dx dt. And they're telling me that that volume is decreasing at a constant rate of 5 cubic centimeters. So, negative 5. And right now I don't know x or dx dt. What is the rate of change of the surface area? So there's another formula, which we just did. And they're looking for the rate of change of that. So we're going to differentiate that. dSA dt equals 12x dx dt. At the instant when the volume is 64. So we're going to go back to our volume formula, which is x cubed. And at the moment that's 64, what's x? 4. Good. So, again, because we now know that x is 4, we can plug it in here and find dx dt so that we can then have it for over here. So negative 5 equals 3 times 4 squared dx dt. What's 16 times 3? 48. So divide both sides by 48. And there's your dx dt. And then we can bring all of this over for finding the rate of change of surface area. 12 times our x is 4, and our dx dt is negative 5 over 48. And the 12 times 4 is 48, so that cancels with the denominator, and we just get negative 5. And surface area is, it's area, so it's centimeters squared per, and everything here is in minutes. Oh, just like the last one. Oh, just a flip of the last one. Alright, so a helium balloon, just so you, obviously volume, I'll give you the two formulas. Volume is 4/3 pi r cubed. Surface area of a sphere is 4 pi r squared. So, start this on your own. Bryce L., I want to hear what your answer is when you're ready. What? He's next on the list, he could get a bonus point. It's not a teacher game, but it's a independent work game. We play by the same rules. You don't like, I can skip your name, you don't have to play.
Well, you already didn't get into it.
You also, by the way, if it's not, you can concede, just like you do in the teacher game if you don't know. You can give in. It's not? What'd you get? Let me steal it. Aaron, what'd you get? 53rds is correct. But we can play teacher as well with Bryce's work. All right, so oh, yeah, don't give anything away. You take away a point. Owen? Dan, you're going to start losing points for inappropriate. That's your warning. Starting now. Go ahead, Owen. Correct. Yeah. When you were solving for DRDT, you're just supposed to divide over 144 pi. So a couple things. It's like you took the square root of that on your own accord. I'm not sure exactly why. And also, his pi should be in the denominator. Right? You're actually dividing over the 144 pi. So now when he goes up and he uses this for DRDT, it should be 25 over 144 pi, and his pi will cancel. And we just have to reduce here. So the 12 and the 144 will become 12, and then 8 and 12 will become 2 and 3, and then we have 50 on top, over 3 on the bottom. And its area, so it's inches squared per, and our unit of time has been minutes. I don't know, maybe those numbers 25 and 144 were just too tempting. We just feel like those are perfect squares, let's take the square root of it. Okay, any questions on this? A little bit more maze-like, but still all the same concept. Do you want to write down a list of the formulas that you need?
Yeah.
Okay. So for a cube, your surface area is 6x squared, and your volume is x cubed. For a sphere, your surface area is 4 pi r squared, and your volume is 4/3 pi r cubed. for a cone, your volume is 1/3 pi r squared h. For a cylinder, your volume is pi r squared h. I don't believe surface area for a cone or a cylinder is going to come up. Let me give them to you just in case they come up on the homework. The cone is, I just don't see this happening. The cone has like lateral surface area, which is the surface area around the outside, which is pi RL, I think, plus the area of the bottom, which is pi r squared. L is your slant height, if you remember. And your surface area for cylinder, you've got the outer part of the cylinder, so that's 2 pi r h, plus you've got 2 circles worth of surface area at the top and the bottom, so it's 2 pi r squared. I don't think you're going to need those, and I need to double check the cone one, because I'm not even sure that's right. Alright, your homework is at the bottom there, it's out of the book.